In this video, we'll be going over some pH calculations for weak base solutions. In this first problem, it asks to calculate the OH concentration, the H plus concentration, and the pH of a 2 molar solution of pyridine C5H5N. So a couple of differences to point out before we start this problem. On weak bases, it's different than weak acids because we're forming OH. So we actually need to show water in this in the ice table, like in our chemical reaction. So reminder number one: show water in your ice table, or else your equation won't make sense. It won't balance. So you need to show water, and then we're just gonna dash it out in your ice table. Reminder number two is that we're working with a base here, so we're not forming hydronium. We're forming hydroxide. So we're going to be finding OH concentration at equilibrium. So at the very end, we need to use this equation to convert it to pH, to calculate pH. So let's get started on this problem. So C5HN, I'll set up my ice table and write our reaction here. And it's going to be, so our pyridine is going to go like this. So it's going to make a, if you remember from the last video, we went over like the structure of amines. So the pyridine looks like this. It has 5 carbons and they're actually in a ring like that. Okay, and it's got alternating double bonds and it has that lone pair right there. Okay, and then on water, we went over how this lone pair is going to grab one of these hydrogens like that. Okay, so the pyridine, the H bond that it forms, so it's going to go from this to looking like this. So the product will look like this. I'm kind of out of space here, so I'll write it here. So the pyridine will look like that. So instead of the lone pair, it's going to have an H there now. And if you remember the formal charges, nitrogen has 5 valence, and we subtract all the dots and dashes. So it's got 4 dashes and no more dots. So it's 5 minus 4. So it's going to be a +1. So that's how the bases pick up a +1 charge. And so this is going to be, and then it's going to make hydroxide as the product. Okay, so I'm not going to draw this whole thing out. I'm just going to summarize it, and I just kind of wanted to point out how it picks up the H, and then it picks up a +1 also. So C5H5NH, and I'm going to write plus right there. Okay, plus OH minus. Okay, so here we go. Set up our ice table, and I'm going to dash out the water before I do anything else. So it says I'm starting with a 2 molar solution, so I write 2 there. None of this is formed yet. None of this is formed yet. So it's going to go down by x, this goes up by x, this goes up by x. This is plenty small enough, and this is plenty big enough for the assumption rule to work fine. So this is going to be 2.0 minus x, and x. Okay, and so I'm going to set this equal to my kb, 1 times 10 to the 7th, or 1.7 times 10 to the negative 9th equals x squared over 2.0. And again, this is going to be really, really small. So we'll see, we could even check it if you want at the end. So x is going to be, x, which is our OH concentration, is going to be equal to the square root of 1.7 times 10 to the negative 9th times 2. And I got 5.8 times 10 to the negative 5th. So I got 5.8 times 10 to the negative 5th. There's 2 ways to go with this right now, because this is OH, and we want the concentration of P. Actually, wait a second. They asked to calculate OH and H plus, so I might as well just calculate H plus right now. So that's going to be KW divided by OH minus. Okay, and for that I get 1.7 times 10 to the negative 10th molar. Now that's still in my calculator, I'll just take the negative log of that result. And so I get, for my pH, I should get something over 7, which I do. I get 9.76 for the pH. Okay, so let's go on to another type of weak base problem. So here's one where they give you pH in this one. So they give us the pH and they give us the initial and they say calculate Kb. So this is very similar to a weak acid problem we did a couple videos ago. So this one, I don't know what pyridine is, so I'm gonna just call it B for base, so I can write my my ice table. So I'm gonna write B plus H2O, and then I'm gonna write BH plus 1 because that's how amines work. They pick up a H and they pick up a charge, and then it's gonna make hydroxide. So I'll set up my ice table, and I'm gonna fill in the information that they're giving me. Okay, so I'm gonna dash out the water, and they told me that this solution is 1.00 times 10 to the negative third, and this amount is nothing. So what they gave me here is this pH is not the OH, so it's not this number because it's the pH. So this will allow me to get the hydronium, and then once I have the hydronium, I can use water's Kw to get the OH. So I have to do a little bit of work, but what they're giving me is this. I have to do a little bit of work to get that, and if I get this, I'll have X. And if I have X, I can figure out what B is at equilibrium. It's going to be 1.00 times 10 negative third minus X right here. Okay, so this is going to be, go up by X, up by X. Okay, and this number right here is what they're giving me when they give me the pH. So I'm going to go like this. I'm going to go POH is 14 minus 10.82. So that is, the POH is 3.18. So my concentration of OH at equilibrium for on the E line, this number right here, is going to be 10 to the negative 3.18. Okay, and for that I get 6.6 times 10 to the negative fourth molar. And so now this also equals the concentration of BH plus at equilibrium, and it also equals X. So this number equals this, and this 1.00. So this is because this is going to be minus X times 10 negative third minus X. So now I have what X is. So I could just plug into my Kb expression. So Kb is going to be the concentration of BH times OH over B at all equilibrium values. So substituting, so this is going to be X times X, and now I know what that is. So it's going to be 6.6 times 10 to the negative fourth squared over 1.00 times 10 negative third minus 6.6 times 10 to the negative fourth. Okay, and so for this I got, for Kb, I got 1.3 times 10 to the negative third, and I'm solving for an equilibrium constant, so it's unitless, the answer here. Okay, so check back, you could check back to the weak acid problem we did like this. We did one just like this, exactly like this, but with a weak acid. And you could kind of take note of the differences and similarities. Very similar, except we had to do a little bit of work to get the OH. So here's the, here are the year turns. Okay, so this one, I forgot my reminders. Remember to show water. Oh yeah. Okay, I kind of totally covered that right now. But anyway, so it says think of your ice table as empty boxes, like this. So you have to go, what is that pH telling me? It's telling you this number, which gave you these blue check marks I put. It gave you X, which allows you to get this number also. Okay, so here's the year turns. Okay, so here's, you'll have to use your appendix for the Kb values. They should be in there for those two. Don't forget to write your reactions out. Write your reactions. Show water. Remember to show water. And use an ice table. Okay, don't take them for granted. I know some students they go, oh, another ice table. I already know how it's going to end up. But just if you just slow down, I see a lot of sloppy mistakes, real simple mistakes. So just be consistent, and then you won't make those types of mistakes. So and then the next your turn is kind of like the one I just did. So where I gave you the pH is given to you, the initial amount's given to you, and then you're asked to calculate KB. All right, that's the end of this video. Good luck on those returns.